Here's another example on differential equations. This one I picked on purpose because it combines the regular functions, the ones that we've seen before a lot, and trigonometric. So it's we're gonna deal with this complex integration. Okay, so it just says that the initial value is, and again, by the way, on every free response that involves differential equations, the part where they ask you to solve differential equation for y, to find y, or same as f of x, with the initial value given, they give you 6 points. 6 points is a lot. So if you can actually solve your differential equation correctly, you get a lot of points just for that one problem. So please review this one too, okay? Let's see. So the rule is, by the way, the initial value is 1, 0. The rule is you want to separate your variables. I'm going to go a little bit faster because you know what to do. So I'm going to multiply both sides by dx. So I like seeing these guys together because they both contain the x value. Now I don't want this one right here. So I'm going to divide both sides by y minus 1 squared, and I will get, I don't want to put dy in the numerator, it just looks ugly, so I always do 1 over. This way you can recognize the appropriate function that you want to use when you integrate, dy equals cosine pi x dx. You know what to do next. You integrate, after you separated your variables, you integrate both sides. Remember, the x values or t values, depending on your problem, you have to be on the right side, and y, the actual function, has to be on the left side. So in order to solve this integral, I don't want to, first of all, don't you think about the putting ln, because it's not just 1 over y minus 1. It's 1 over y minus 1 squared. So this involves the power of the function. So first I'm going to rewrite it as y minus 1 to the power of negative 2, because that's how we normally start. This one right here, you see, it's not just x, it's pi x. So you need to use not the chain rule. If it was just a regular derivative, you would put pi and you would pull it out, but you're integrating. So instead of putting a pi outside, you're gonna pull out its reciprocal, 1 over pi, because you're integrating again. So be careful, please. Integral of cosine is sine. And another common mistake, when kids see something like this, they always say, oh, okay, so the derivative of cosine is sine. But we're actually looking for a function, something that we can differentiate and get cosine. So the derivative of sine is cosine. All right, so that's why integral of cosine equals to sine. Oh, but God forbid, you don't want to forget this cupcake. So it is really, really, really important. So if you don't put it at the end, you're going to ruin the whole problem, and you'll probably get 1 point or 2 out of 6. So now let's integrate this part. I'm going to move to the next page. So you get, it was y minus 1, right? So you get y minus 1, negative 2 plus 1, over negative 2 plus 1, which is negative 1. So I'm going to put negative 1 here. Equals, and what do we have? 1 over pi sine pi x plus c. Okay, now you get negative 1 on the top as your exponent. I don't want to see any negative exponents, so I'm going to do negative 1 over y minus 1, and it's just y minus 1, because the exponent becomes just 1 when you flip your fraction. So why do I want to use parentheses? I don't. Equals 1 over pi sine pi x plus c. Now, I never solve for y right away, so I always try to find, if possible, I always try to find c, and then plug in whatever the number is for c, and then solve for y and finish my equation. It just seems easier. Also, when you have something like this, see, you have 1 over pi, that's a constant, and you have another constant here. So when you see too many constants, like more than one, so you always say, you know what, let me do something to this whole the expression so that I can express, somehow I want to combine my constants and replace it with one big giant c or k. So actually the readers love seeing that. So trust me, if I just had sine pi x plus c, that would be perfect. Then you just have one c. But you have another constant 1 over pi. Remember how in previous problems we had something like this, 2x plus, can't remember, c. And then you have to split it up and you get e to the 2x times e to the c, right? And you replace it with big C. So that's the same type of a strategy. So let me get rid of this mess. And this. And this. Too many colors. 1 over pi. Sorry. Sine pi x plus c. So look what I'm going to do. Again, you don't have to do it. You will still get the right answer. It's just going to be complicated. So I'm trying to make my life easier. 1 over pi. No. This is actually here. Sine pi x over pi plus c. Agreed? So the common denominator is pi. Now, if I find a common denominator and combine and get just one fraction, I'm going to get negative 1 over y minus 1 equals, you'll see why I'm doing this, sine pi x plus pi c. See right there, you get another constant all over pi. You're probably thinking, what about this constant? Okay, now this thing I can replace with k or big C. And now I'm gonna, actually I don't like this negative right here, it bothers me, so I'm gonna rewrite this. You don't have to, but I'm picky. So 1 over 1 minus y, it's the same thing. I hope you understand that. So equals sine pi x plus fat c all over pi. Okay, good. Now I'm going to replace my given initial condition, 1, 0, and see what happens. I want to find c. New page. 1 over 1 minus 0 equals a sine of pi, x is 1, so I'm just going to leave it as pi, plus c all over pi. So I get 1 equals, sine of pi is 0. So you get c over pi, therefore c equals pi. Good. Do not circle anything on your actual free response. Finally, we get our function as, let me see, go back, 1 over 1 minus y equals, so for this c, I'm going to put pi. Okay, so we get 1 over 1 minus y equals sine of pi x plus pi all over pi. and I can just put 1 minus y equals pi proportion over sine pi x plus another pi. Oh my god, this looks like a nightmare. And now I'm going to solve it for y. So I get y. I'm going to move y to the right side. So I get 1 minus pi over sine pi x plus pi equals y. I think I'm done. Yeah, so this is x right here.